Hi! In the next 20 minutes, you will learn what are web workers and how they can help you to optimize the performance of your web applications created with Angular or any other JavaScript framework. We will start with a simple mental model to understand the general concept of web workers, and at the end of the video we will see everything in action and we'll try to optimize the bottleneck in our demo application and make it about 16 times faster. If it is your first time on my channel, my name is Dmitry, and here you can find a lot of advanced and unique Angular tutorials and courses. So if you are a passionate Angular developer, please subscribe right now and let's get started with web workers. I'm pretty sure that most of you are aware that JavaScript is a single thread language. But what does it mean? It means that JavaScript has only one thread called main, and it can perform only one task at a time. If we block this main thread with some expensive task, then the browser window just hangs and the user can do basically nothing. User cannot even select the text or call the context menu, like really nothing. Everything is just blocked. I'm not gonna dive too deep into how JavaScript engine works and all these nuances. There are a lot of very cool and insightful videos and talks here on the YouTube. You can find them and watch, but I will give you some very simple mental model that can give you some understanding of what is going on under the hood, and it will be enough to understand what we're going to do later in this video. So just imagine yourself at the work. Time after time you get some tasks that are not so complicated and you can perform them in a reasonable amount of time. In the best case it should be, well, somewhere up to 1 hour, which is pretty comfortable. But then suddenly you get a task to perform a live coding stream for at least 8 hours. That sucks, because this type of task cannot be split into chunks, and once you go live, all other tasks you have to perform, they are blocked and you cannot proceed with them until you finish this coding stream. In this analogy, you are the main thread in the JavaScript engine of the browser. The tasks are JavaScript functions and scripts that have to be executed, and for you, as for JavaScript main thread, the reasonable time to execute those tasks are up to 16 milliseconds. If the task or script is executed within this period of time, your users will get the best and smooth experience. Otherwise, the interaction with your UI might be very glitchy. You might say that, in JavaScript I can be asynchronous, so following this analogy, I could reschedule this stream to another date, and in such a way I will unblock myself and proceed to perform tasks. Yes, that's true, but in this case you just postponed the execution of the task. You didn't solve the real problem, because when time comes you would need to still perform this task for 8 hours. You would still need to do this live streaming, and it doesn't matter, either you will be blocked right now or later. You know what I mean? So what would be the solution in this case? Well, we could delegate this task to a coworker who also knows Angular and can perform a live streaming as well, and to do it even probably more efficient and better. We just send our colleague a message and ask to perform this live stream, and also we can provide some required and necessary data like slides, etc. And because our colleague now cares about this task, we can continue with other tasks. And once the streaming is done, we will be notified by the colleague that the stream is over, and they can give us back some other data like video recordings or some statistics, etc. And from it you can already schedule another task. Maybe you would like to analyze these statistics and so on. But this is pretty easy task that can be done in 1 hour, right? And this is exactly what web workers are doing. With web workers, you can offload this expensive computations, these expensive tasks, you offload from the main thread to the separate thread that is created specifically for the web worker. So while the web worker is processing this expensive task, the main thread remains unblocked and always available. All right, now let's try to have a look at how this everything would look like in a real application. So for this lesson, I've created a super simple mini Angular application where user can choose some image and then apply some filter to it. Likewise, you do it in Instagram. So I can choose some image. Let's choose the small one for now. And once I have chosen this file, this image, the load image method will be involved. There I choose this file first of all, then I create a bitmap from it, and then draw this image inside the canvas. And here in the template, I have this canvas element right here. So there will be added this image I have chosen. So then once we have the image there, I can click this apply filter button and it will involve the apply filter method. So let's open it. And once I click it, then happens the following. We read data from the image data from the canvas, and this data, it is represented like huge array that consists of thousands and thousands elements, and each element in this array, it represents single pixel in this image and defines which color of this pixel should be, what is the opacity, what is the alpha channel for that, and so on. So huge array and a lot of data there. And then once we get this data, I apply this crazy expensive image filter, which turns our image into, well, this. Probably aesthetically not the best filter, but the main feature of this filter is that it is so expensive. I mean, I typed in ChatGPT like, give me the most expensive image filter, and it generated me this crazy stuff. I have no idea what is going on there, but I see that it is extremely huge and extremely expensive. And once this data is processed by this crazy expensive image filter, then we put this image data back to the canvas, and then you will see this modified image. When it comes to performance and optimization, it is crucial to do measurements. Otherwise, you will not know if your optimization was effective or not. So before we will start, I would suggest you to perform some initial measurement in order to know how much time currently it takes to apply this filter. I'm going to just refresh the application and open the dev tools. And here I have to go into performance tab and reduce the CPU first of all. In such a way I will emulate some old device, right? And now I can actually choose the file, and this time let's upload the big image. So the bigger image, the harder to process it, right? So here we go, everything is uploaded. And now I can start recording, and let's try to apply our filter. And as you can see, I applied the filter, and for couple of seconds my UI was completely blocked. This is because this expensive calculation has blocked the main thread, and that's why I couldn't even open the context menu. Okay, so now let's stop the recording and have a look. What do we have here? So here is our task. This is the click I performed by clicking this button, and it took 3.5 seconds. If you remember, I told that it has to be normally executed in up to 16 milliseconds. So definitely we have some performance issues, and definitely we have to improve something. And here you can see that, yeah, this crazy expensive image filter took 3 seconds to apply this crazy expensive filter. So now let's have a look how we could optimize it by using WebWorkers. For that, I'm going to jump to my source code, and create our first web worker. So somewhere here, I'm going to create another private property called worker. And once my component was initialized, then we will create a new instance of the worker like that. And here we have to provide the path to the JavaScript file that will be actually executed in this worker context. Currently, I don't have such a file, and we can create it either manually, or if you use Angular, you can generate it by using Angular CLI. And exactly that I'm going to do. So let me open a new terminal, and here we can run this command that will generate image filter worker. So once I hit enter, you can see that there were created and updated some files. First of all, there was created TypeScript config for the worker, and this TypeScript config has been added to the Angular JSON file. And there was generated the script for the future web worker itself. So let's currently remove everything from here. We will add the logic a bit later. What we have to do right now is to register this TypeScript file as a worker. So let's go there, and here we have to provide the URL to this image filter worker. And we can construct this new URL using the URL constructor. And here I have to provide the relative path to my worker. It is located next to app components. So here I type / image filter worker. I hope I did no typos here. Okay, looks good. And as a second parameter, I have to provide the base URL that I can take from import meta URL. So this import meta URL, it contains the path to this JavaScript module. All right, so and this is needed in order to properly resolve the relative path to this JavaScript file. But anyway, so once I save it, we successfully register the web worker, and we can save it. But before, I would suggest you to restart your application because we modified the Angular JSON file. So yeah, once I restarted everything, and here I try to reload my page, and you can see that everything works fine. We see no errors in the console, which means that web worker has been successfully registered. And by the way, you can also unregister it, so to say, terminate it. Maybe you would like to do it inside ng on destroy lifecycle hook. So here you can just call the terminate method of this worker, and it will like terminate the web worker if at some point in time you need it. Okay, good. Now the question is how the main thread talks to the web worker and vice versa. Well, they communicate via dispatching and receiving messages. In order to dispatch a message from the main thread to the web worker, you have to use the post message method. And here you can dispatch any data you like, the object, the array, or a simple string like that. So once you dispatch the message, the web worker can receive it by implementing the event listener and listening for the message event. And here inside this data, there will be our message, and you can actually see that by console logging that like this. So I save it, and then I go to my application, reload the page, and you can see here the message that was received from the main thread. And the same way also the worker can send the message to the main thread and provide some data. For example, after some period of time, for example 4 seconds, we can send a post message to the main thread and say something like hi from worker, whatever. And in order to receive this message from the web worker, we can do the similar thing. We have to implement on message handler, and it can be just a simple function. And this function also receives the event where you can destructure the data, and inside this data will be the value that this worker dispatched. So in our case, this is this string, and I can console log this message as well. So here we go, and now I can save and test it. So I reload the page. Here you can see that we immediately dispatched value to the web worker, and then after 4 seconds we got back the message from the worker and console logged it here. Alright, I hope this part is pretty much clear so we can move forward. And now we're going to do our final step in our refactoring, and namely I'm going to offload this heavy computation, this crazy expensive image filter into the WebWorker context. And once the WebWorker processes everything, it will return back the processed data, and we will just insert this new image into the canvas. So what we have to do, first of all, we have to remove this post message and do that inside our apply filter method. So once I check that the image data exists, we can post message and provide the image data to our web worker. So here we go. So this part is not needed anymore, and this part where we already put the processed image back to the canvas, we are going to move out of here and define it inside on message, because here we will get already a processed image. So let's rename it like that and remove this part. So here we go. All right, and then I would need to copy this crazy expensive filter, cut it from here and insert somewhere there. And then instead of this stuff, I would need to process data that I received from the main thread. So here will be a huge array that I provide here, process it, and then this processed image has to be sent back to the main thread. So for that, I will use the post message method and provide the processed image just like that. And this is it. Actually, we can save and already check how everything works. So let's go to the performance tab. Let's clear everything here, upload this big image, then start recording and apply our filter. And you can see that first of all, it performed faster. And besides that, if we pull it up a little bit, you can see that this time the same task took 192 milliseconds, which is compared to the previous result, 3.5 seconds. It is a huge boost. And this is because if you zoom it a little bit and follow the call stack, you can see that we applied the filter, which took only 35 milliseconds, and then everything was delegated to the separate worker thread. And you can see that here was executed our crazy expensive image filter, and then data was sent back to our worker on message method. And there we already inserted the processed image into the canvas. Another thing you have to keep in mind when you transfer data between main thread and web worker is that when you transfer the data is being cloned by a structural clone function. It means that when it comes to a huge object or array, it might take some time in order to create the copy of this object. And you can optimize it by using transferable objects. Transferable objects, those are objects that can switch their context. So they can be transferred from the main thread context to the web worker without cloning that. There is a list of objects that support this feature. You can see it right here. In my case, it is a image bitmap, so it can be safely transferred. So we can do that, and I will quickly show you how to do that. So in post message function or method, you can provide a second parameter, which is array of transferable. There you have to provide the buffer. So in my case, I have to define processed image, and inside the data, I have to provide the buffer just like that. And after that, I can do the same thing also inside the app component file. And it means that now when I post the message and post this data, the main thread kind of overtakes the ownership of this array to the WebWorker context, and now the WebWorker is the owner of this array and can perform different operations on it, while the WebWorker has ownership of this array. The main thread cannot access it. You cannot read or write into this array. But once the WebWorker finished the processing and post the message back to the main thread, now the ownership goes back to the main thread. And this operation, this context switching happens like immediately, so you don't have to waste resources and time for cloning the array or object. You just switch the ownership from one context to another. So as you can see, WebWorkers can be a really powerful tool that can boost performance of your web applications. However, like with any other technology, you have to keep in mind that it has its own disadvantages and limitations. For example, you cannot manipulate with DOM elements from WebWorker. It just doesn't have access to it. Also, you don't have access to the document object and window object. WebWorkers, they have its own global object called self, but it is different from the window object. Besides that, if you use server-side rendering with your Angular application, you have to care about writing the fallback for the WebWorkers, because on that environment, WebWorkers are not supported. So these and some other limitations, they a little bit narrow the area where you can apply WebWorkers. And the best use case for them is the example we had in this video, some heavy computation, some heavy expensive data processing operations. This is where WebWorkers are really good. Alright, that's it for now. I hope this video was useful, and if so, please share it with your colleagues and friends, and don't forget to check out my Angular courses that can boost your career and Angular skills to the next level. Don't forget to leave your comments in the comment section. It would be very interesting to hear your opinion about WebWorkers. Maybe you know some interesting use cases from your career. Please share it with us. I think it would be a really interesting discussion. Otherwise, I wish you a productive week ahead. Stay safe and see you in the next video.